Hello. Today we are going to focus on creating and interpreting scatter plots. Remember to fill in your table of contents. So we are starting Unit 6, which is bivariate data. Bivariate means two. We are comparing two sets of data. And the first one we are going to look at are scatter plots. I'm on page 97 to 98. Remember, your page numbers might be different than mine. Our objective today is to create, identify, and predict data written in a scatter plot. And our essential question is, how do I use a line of best fit to make predictions from scatter plots? If you need to pause the video at any time to write this down, feel free to do so. A scatter plot is a graph with points plotted that show a relationship between two different sets of data. This is considered bivariate data. Because there are two different variables. The association between these two sets of data describes how the sets of data are related. We have three different types of association. So we have positive, when we have a positive association, both X and Y increase. We can see the points are generally increasing or moving in that direction. We also have negative association, which means that as X increases, Y decreases. So we can see the coordinates here are moving in a negative direction. And then what we have is called a no association. Okay, so that means there's no relationship between X and Y. So you can see over here the coordinates are just kind of all over the place, so that shows a no relationship between them. So being able to relate this to real-world examples, when we have a positive association, we can see as X increases, Y increases. A real-world example of that would be the temperature outside and the number of people at the beach. The higher the temperature is, the more people we would expect to go to the beach. For a negative association, we would see that as X increases, Y decreases. A real-world explanation of this would be the distance you have traveled and the amount of fuel or gas left in your tank. The more you drive your car, the less gas you will have in your tank. And then a no association, we can see that there's no relationship between the X and the Y values. One variable does not have an effect on the other. So, for instance, the age of a person and the number of pets they own. Some people don't own any pets, while others will have more. So it doesn't depend on the other. We have some more vocabulary when we're talking about scatter plots. So we have what we call a cluster. It is a set of closely grouped data. The data can cluster around a point or a line. And then we have what we call an outlier. An outlier is a data point that is very different from the rest of the data. It's kind of sticking out. So we can see that we have two clusters . And we can identify them by circling them here on the graph. So we have these closely related points. And then we have one outlier. So our outlier is this point that's way by itself. It's kind of away from all the others. And that's located roughly at 35 to 28. When we're talking about scatter plots, you might have to estimate. So we can see that this is 35, but up here it's kind of close to 30. So if you said 29, that'd be close. If you said 27, that'd be close. We're going to call that 35, 28. So our vocabulary words here, we have cluster and an outlier. All right, so now we're going to focus on creating our first scatter plot. So what we need to do is we need to plot these points on the graph. And remember, when we're talking about a scatter plot, it's an estimate or close to. So we have 2.5 and 68. So 2.5, I would say, is in the middle of 2 and 3. And then I need to go up to 68. So that's going to be relatively close to 70, but not quite there. So I'm going to put a coordinate there. I might mark it off as I do it. So then I have 0.5 to 71, 4 to 98, 3 to 91, 0 and 2500ths to 40. So if this is 0.5, this line here, 0.25 is going to be somewhere in the middle there. I'm going to go up to 40. 3.5 to 83. 2 to 75. So you can see we are creating this scatter plot. Points aren't necessarily exact, but they should be relatively close. So this is about what my graph looks like. Yours could be slightly different, but again, it should be close to this. And what we notice here is that this is a positive correlation. Those are increasing. Okay, so now we're going to look at what we call a trend line. A trend line is a straight line that comes as close as possible to the points on a scatter plot. They are approximately the same number of points above and below the line. Ignore any outliers. So when we are creating a trend line, we want to draw a straight line, and we want to include as many points above and below as possible. These are approximate values, so your line might be slightly different than mine. And then we use these lines to make predictions. So we draw a line that's going to kind of encompass as many points as possible and roughly the same number above and below. So it's kind of like an average. And then we want to use it to make a prediction. So we want to predict how much you should expect to have to pay in repairs for an 8-year-old car. So that's going to be here. And then if we follow the line we drew, it's about here. So it looks like it's above 900. So we'll say it's about 950. So this word approximately is an estimate. It's not exact. It's just an idea. So now let's take it a little bit further and create an actual equation for that line so we can use it to make predictions. So what we want to do is, again, draw that trend line. And if you don't get it exactly right the first time, you can try it again. I really recommend using a ruler. So there's a couple of ways to do this. What we really need to do is to find the slope of the line we drew and to find the y-intercept. So we've done this before. So when we are writing an equation, just like we have in the past, it's in the form y equals mx plus b. We need to find our slope, or our m, and our b, our y-intercept. So when I look at the equation I just drew, I can see that my b, where it crosses this y-axis, is at 0. So my b is 0. And then I need to find my slope. So remember, you kind of want to use exact lattice points, and this is an approximate. So let's see, I can see that I'm going to rise 200. One thing about scatter plots, pay close attention to what you're changing by on the y or the x. So I'm going up 200, and then my run is 2. So when I reduce that, my slope is 100. So that means when I plug it into the equation, my equation becomes y equals 100x plus 0. And remember, we don't add that plus 0 at the end. So I'm going to erase that. So our equation becomes y equals 100x. Okay, so let's practice that again. So our first step is to draw a trend line. So I need to draw the trend line on my graph. Using a ruler is very helpful. Remember, you want it to be roughly down the center of your coordinates. We need to then find our slope and our y-intercept. For me, it's easier to find the y-intercept. So I'm going to come over here and take a look. And on my trend line, I crossed at 100. And now I'm going to work to find my slope. Remember, this is a rough estimate, but as I look, my closest lattice point is about here. So I'm going to increase, so there's 100, 200, so my rise is 200, because each of these is 100. And then my run, 10, 20, 30. So I want to reduce that slope so I can see that this is going to become 20 over 3. So my equation would be y equals 20/3 x plus 100. You could also change that to a decimal and do 20 divided by 3. That would be okay as well. So hopefully at this time, you understand how to create a scatter plot, how to determine its association, positive, negative, or no association, and how to write a trend line. We use this now to make predictions.